And very good afternoon once again. So welcome back, guys. So in today's class, we are going to discuss the next topic of probability distribution, that is Poisson distribution. So very good afternoon and welcome everybody. So let's see who all are live with us now. So we are having Preeti Sharma, Aklandeshwari, Natasha, Swati Giri, Anmol Agarwal, Manisha Raspurohit, Pramod, Ananya, Mike Roy, Ritu Tiwari, Ankita Singh, Prasanta, Shreya, Arpisha, Ravish Chaudhary, Tamanna, Surya Kumari, Savitri, Aditya Darshan, Manish Jain, Darshan Sharma, Aisha Sood, great. So many people are live now. Anmol, Shri Farhan, and Samina. So great. Welcome everybody. So we are starting with the next topic, that is Poisson distribution. So basically, what do we understand by the term Poisson distribution and who has described this theory? This theory was given by Simon Dennis Poisson from France in the 1837. So he gave this theory like roughly 200 years back. So, what are the basic conditions of the Poisson model that we have to understand? So, the first basic thing here is whenever the probability of success is very, very low, when the probability of success is very, very low, then we use Poisson distribution. So, this is the first condition. So, probability of success in very small time is very, very low. So we find the probability of success in a limited period of time. And in that time interval, the probability is very low. So the probability of having success in this time interval is independent of T as well as earlier successes. So here also trials must be independent of each other. All those trials which had already been occurred, so it will not affect the current event. So here also the events are independent. So let us write the basic points. So the first thing was probability of success is very, very low. Probability of success is very low. So it is very low such that P tends to 0. It is very low such that probability tends to 0. Now, what this means tend means it is near to 0. It is almost 0, but not 0. So whenever it is written P, then arrow and then 0, it shows that probability is close to 0, but not equal to 0. The second condition is the number. ओके मैं चेक करता हूँ वापस मैं इसको स्विच कर लेता हूँ दूसरे नंबर की ओके मैं स्विच कर गया है तो एक बार आप वापस चेक करिएगा अब थोड़ी क्लैरिटी आनी चाहिए नॉइज परफेक्ट फ्लक्चुएट अभी हो रहा है एक वीडियो ऑन कर लेता हूँ वापस वो विजिबल हो जाएगा अगर नहीं हो रहा तो अब ठीक है Okay. So we are discussing the basic conditions of Poisson distribution. So the first condition is that the probability of success is very low, such that P tends to 0. Now, the second condition is number of trials are very large. Number of trials are very large such that n tends to infinity. N tends to infinity. So here n is not like a small number, it is a very big number. Also, n is always a positive number and always a whole number. So number of trials are large, they tend to infinity, but not equal to infinity. Then it is positive and then a whole number. Other conditions are similar to binomial distribution. अच्छा, मैं एक बार स्टॉप करके वापस रिजॉइन करता हूँ. ओके ओके, ठीक है. और फिर वापस मैं स्टार्टिंग से शुरू करूँ या कंटिन्यू करना है? So guys, we were discussing about the conditions. So what are the basic conditions of probability distribution in case of Poisson distribution? So the first condition.
Hello.
And these outcomes will be mutually exclusive. So the outcome, yes, sir. Okay. So here the trials must be independent of each other. Trials कैसे होने चाहिए? एक दूसरे से independent होने चाहिए. That means एक का effect दूसरे के ऊपर नहीं आना चाहिए. This is the meaning of independent trials. Also, the outcomes, there are only two outcomes. One is success, other one is failure. और ये जो दोनों outcomes हैं, ये कैसे होंगे? These outcomes will be mutually exclusive. mutually exclusive, and exhaustive. Mutually exclusive and exhaustive. So all these are the possible outcomes. And overall, the total of probability will be equal to 1. Since they are exhaustive, so the total probability is always equal to 1. Okay, perfect. So these were the basic conditions. Now let us come to the practical portion, that is the formulas. So formulas in case of Poisson distribution. So now the first formula for Poisson distribution is the calculation of mean. Calculation of mean. Mean is denoted by a small m. Also you can write mu. So m or mu, it is the mean. Now what is the formula? The formula is same, n into p. N into p. N denotes number of trials and p denotes probability of success. Second formula is for variance. Now, in case of variance, what will be the formula? The formula is n into p. We don't write q here. So, np. Or you can say root of mean. Root of mean. Yes, sir. आज हाँ क्वेरी में वही आ रहा है वापस. You are not audible, voice is not coming, video. अच्छा, ओके, आपका भी नहीं है रिसीव हो रहा है. आज तो फ्लक्चुएशन ज्यादा हो रहा है. रोज तो ओके होता है. मैं एक पूछ के आता हूँ, दूसरा अगर कोई ऑप्शन होता है मैं उससे कनेक्ट करता हूँ ना. पॉज कर दूं? ओके, आप वहाँ पे पॉज करवा दीजिए, मैं एक बार दूसरा कनेक्शन. So formulas of Poisson distribution. So Poisson distribution की जो formulas है that are very very easy. इतनी easy है वो शुरू होते ही खत्म हो जाते हैं. So the first formula for Poisson distribution जो भी हमने discuss किया that is basically for mean. Mean is n multiplied by p. Mean is simply n into p. The second formula is for variance. Variance is also exactly the same, that is n into p. And third one is standard deviation, that is root of np. Root of np. So in case of Poisson distribution, mean and variance both are equal. ये दोनों क्या हो जाएंगे? Equal हो जाएंगे. Now variance का formula np क्यों है? Because we know that in case of Poisson distribution, p tends to 0. Now when p tends to 0, this implies that q tends to 1. So q is near to 1. That is why we have written the formula NP. So these are the standard formulas for calculation of mean, variance, and standard deviation. Now comes the fourth formula. The fourth formula is for calculation of probability. Now, in case of Poisson, how do we calculate probability? So it is e to the power of minus m to the power of x divided by factorial x. Divide by factorial x. So here, what is m? It is simply mean. What about x? X is always the required number. Whatever we have to calculate, that is denoted by x. And what about e? E is known as exponential value. E is known as exponential value. So what is e to the power of 1? It is 2.7183. E to the power of 1 is 2.7183. Now, as per requirement, you can modify this. If you require e to the power of 2, you can write 2.7183 whole square. If you require e to the power of minus 1, then you can write 2.7183 whole to the power of minus 1. Okay, so these are the four formulas for Poisson distribution. So the first formula is mean, n into p. Second formula is variance, again n into p. Third formula is for standard deviation, that is root of np. And the last one is the formula for probability, e to the power of m minus m to the power of x divided by factorial x. Okay, so now let us start with some questions first. 16.11. So Vaishnavi, I have started from the beginning. So मैंने पहले कुछ नहीं बताया. We are doing from scratch. So no need to worry. Okay. So this is the first question for today, which we are doing. So 16.11. So this time, what you have to do, P is Px equal to 2 equals Px equal to 3. These are given. Px equal to 2 and Px equal to 3. This is given. Now, what is the requirement? Our requirement is find the mean and standard deviation of x, where x is a Poisson variate satisfying this condition. Now, the question has given an equation. The question has given it is Poisson distribution. Now we are supposed to calculate mean and standard deviation. So how do we calculate? So just apply the formula e to the power of minus m to the power of 2 upon factorial 2 equal to e to the power of minus m to the power of 3 upon factorial 3. Now you can do the cancellations and get the result. So let's cancel e to the power of minus m. M square will also get cancelled. So we are left with factorial 3 is 6 upon 2 is equal to m. Therefore, mean is equal to 3. Mean is equal to 3. So in this way, we have computed mean. Now we require standard deviation. So standard deviation is basically root of mean. Why so? Because mean and variance both are equal. So we can find the square root of mean, we will get the standard deviation. Therefore, root of 3, that is 1.732, this becomes your standard deviation. Okay. So this was 16.11. Now, before moving further, let's do some simple questions, some easy questions, so that you can have some confidence. So let's say we are having n number of trials and value of n is 1000, and probability of success is very, very low. That they have, yes, sir. इमेज नहीं आ रही, आपकी वॉइस क्लियर नहीं आ रही है। अच्छा, फ्लक्चुएशन हो रहा है अभी भी। अच्छा, वरी में तो अब तो मतलब बच्चा आंसर दे रहे हैं, अब तो ओके आ रहा है। पहले वो प्रॉब्लम थी, उसके बाद बच्चों ने वो डाउट्स पूछा कि वापस प्रॉब्लम थी। जैसे बच्चों को एक मैसेज आया, बोल दैट इज ओके नाउ, इमेज लग रहा है। अच्छा, ऑडियो क्लियर तो उसमें कोई इशू नहीं है, क्योंकि वीडियो में तो चलो ज्यादा प्रॉब्लम नहीं है, मेरी स्क्रीन दिख जानी चाहिए, स्क्रीन विजिबल है मेरी। हाँ, फिर चलेगा, फिर कोई इशू नहीं है। दैट्स ऑल, वो चलेगा। Okay, so Navin says it is all right now. Okay, that's great. Perfect. So N and P is given to us and we have to calculate mean. So we can apply the formula N multiplied by P. So it will be 1000 into 1 by 100. That is 10. So 10 will become the mean. Now, in case you have to calculate variance, so it is same. Mean and variance both are equal. So it will be exactly 10 again. And if you have to calculate standard deviation, it will be root of 10. Root of 10. So in this way, we can easily calculate all the possibilities. All the results. Now let's move on. 12th illustration, example number 12. The probability that a random variable x follows Poisson distribution would assume a positive value is given. Okay, so this time a value is given and we have to calculate mode of the distribution. We have to calculate mode. Now, what is the condition for mode here? Let us understand that first. So you can write calculation of mode. Calculation of mode. So it is similar to binomial distribution. So what is the condition? If n into p is a whole number, if n into p is a whole number like k, then mode is equal to k and k minus 1. So if n into p means mean. If mean is a whole number, then mode will be k and k minus 1. So it can have one mode or two mode. And if n into p is not a whole number, if it is not a whole number, then the mode will be k. Then mode is equal to k. So let's say if n and p are given, n is 100 and probability is 1 by 20. So what we are getting? We are getting 5. So it is a whole number. It's a whole number. So what will be mode? Mode will be 5 and another number will be 5 minus 1, that is 4. So 5 and 4, these will become the two modes. In case n into p is 90 and this is 1 by 20. So this time mean is 4.5. Now whenever the mean is into decimal, remove the decimal portion and you will get the mode. So mode will be this time only 4. So whenever it is in decimal, ignore the decimal portion, you will get mode. So here the mode will be 4. Now, this 12th example says you are given the value and find the mode in this case. So let us calculate. So what will be x? X is exactly not given. It says the probability of random variable x follows the Poisson distribution would assume a positive value. So value can be anything 0, 1, 2, and so on up to infinity. This is the value of x. Now, whenever this is the case, what we have to do? We have to find the positive number. Now, positive implies 1, 2, 3, and so on up to infinite. So, out of all these numbers, we have to exclude 0. Out of all these, we have to exclude 0. Therefore, we can apply the shortcut formula 1 minus none. 1 minus none, that is px equal to 0. Now, what is the formula for px equal to 0? So 1 minus e to the power of minus m to the power of x upon factorial x. And in place of x, you have written 0. Now, the value of this solution is already given in the question. That is 1 minus e to the power of minus 2.7. So let us simplify this. M to the power of 0 is 1. Factorial 0 is also 1. So we are left with simply 1 minus e to the power of minus m equal to 1 minus e to the power of minus 2.7. So 1 will cancel from both the sides. On comparing, we are getting mean equal to 2.7. So mean is 2.7. Now, mean is 2.7. Then how to calculate further mode? Then mode will be only 2. Since it is into decimal, remove the decimal portion and you will get mode. So final mode will be 2. Okay. So in this question, basically what was given that the probability is 1 minus e to the power of minus 2.7. Now we know that overall values can lie from 0 to infinite, but we require the probability for only positive numbers. So since only positive number is required, so we can apply the formula 1 minus none. None means px equal to 0. So in this way, we can easily get the result. So always take care that we don't have to round off. Just ignore the decimal portion as we have done in binomial distribution. Okay, Anmol? The next one, 16.13. The standard deviation of Poisson variate is 1.732. So this is the standard deviation. Now, what is the probability that variate lies between minus 2.3 to 3.68? So variate means variable. Variable lies between these two values. Now, between these two, what can be the possible value of x? So we know that x can never be negative. X can never be negative. X can become 0 or it can be positive. Also, in case of positive, it will always be a whole number and not into decimal. Therefore, in place of x, we will write 0, 1, 2, 3. 4 will not come because 4 does not come within this element. Therefore, the value of x will be 0, 1, 2, and 3. So this is the value of x. So first of all, what is the formula for probability here? E to the power of minus m, m to the power of x upon factorial x. So X is already available with us, but mean is not available. So we have to calculate mean. So to calculate mean, standard deviation is given. So SD is root of M, and it is 1.732. So squaring both sides, we are getting M equal to 3. So from here, we have computed mean. So mean is 3. Now apply this formula. E to the power of minus 3, 3 to the power of 0. So in this way, you have to take all the possible values. So next will be 2, and then it will be 3, and then it will be 3. So we have taken x as 0, 1, 2, and then 3. We can take common. So e to the power of minus 3 will become common. We are left with 1 plus 3 plus 3 square is 9. 9 by 2 is 4.5. Then 3 cube. 3 cube is 27. Divide by factorial 3 is 6. Okay. So let me explain once again from the beginning this question, because this question is a bit challenging. So question में क्या given था? Standard deviation. So with the help of standard deviation, we have computed mean. तो mean कैसा आएगा? It is the square of standard deviation. तो जैसे हमने square किया, we have got mean as 3. Now it's turn for x. How to calculate x? So question is given that variate lies between these two values. But we know that variable is not negative. Also, variable is always a whole number. So what are the positive whole numbers which lie between these values? So these whole numbers are 0, 1, 2, and 3. So now we have applied this in the formula and get the result. Now you can simplify this. So how much we are getting? 27 upon 6 is how much? 4.5. This is also 4.59 plus 4, 13. So 13 into e to the power of minus 3. Also, you can write 13 upon 2.7183 to the power of 3. Now divide this and get the result. So your answer is, final answer is 0.65. 0.65 becomes your final answer. Okay. So Dimple has given the answer. Savitri has also given. Great. So this was the example number 13. Now 14 is also equation-based question, which we have done the first example. So this easily you can try. Then the next one is 15. Next one is 15. Let us understand the question. Between 9 and 10 a.m., the average number of phone calls per minute coming into the switchboard of a company is 4. Now, from this language, we have to understand that average is given. Average is given. What is the average? Average is 4. Now, find the probability that during one particular minute, there will be no phone calls. So we require probability, and to calculate probability, two things are required. One is mean and second is x. So what is mean? It is average, and that average is given in the question 4. Now x. The first part is no phone call. So x will be 0, 0 calls. Now apply the formula e to the power of minus 4, 4 to the power of 0 upon factorial 0. So we are getting e to the power of minus 4. Now you can simplify this and get the results. Okay. So your answer is 0.018. 0.018. This is the first question of 15th example. Now let's see the second question also. At most 3 phone calls. What is required? At most 3 phone calls. That means maximum 3 calls, not more than 3. Not more than 3. So what will be the value of x? X will be 0, 1, 2, and 3. X will be 0, 1, 2, and 3. Because not more than 3 calls is required. So we will write probability of x equal to 0, 1, 2, 3. So let us apply this formula. E to the power of minus 4, 4 to the power of 0 upon factorial 0. Then substitute the value 1, then 2, and at last 3. So all the values we have substituted. Now you can take common. E to the power of minus 4 is taken as common. We are left with 1 plus 4 plus 8 plus 4 cube. 4 cube is how much? 54 divided by 6. So e to the power of minus 4 we have already computed above 0.018 multiplied by all these. It will be 71 by 3. So the final result is 0.43. 0.43. So in this way, you can get your result. Okay. So this was example number 15. Any doubt till here? So Ms. Khan has also given the answer. Dimple has given. So Poisson distribution is basically very, very small topic, and this is having just 4 simple formulas. And with the help of those formulas, you can easily calculate all your results. Now the next one, 16.16. If 2% of electric bulbs manufactured by a company are known to be defective. Now, as per the situation, what is given? 2% are defective. What is the probability that in a sample of 150 electric bulbs, so we have taken the sample of 150 electric bulbs. So what is the probability that exactly one defective bulb is there? What is required? One defective bulb. So let's calculate. So what is 2% here? 2% is the probability of defectives. So 2% can be written as 0.02. 150 bulbs are there. This is n equal to 150. So how to calculate mean? Mean will be n into p. So 150 into 2%, it will be 3. So mean is equal to 3 here. Then what is x? exactly one defective bulb. So x will be equal to 1. X will be equal to 1. And in case of second part, more than 2 defective. So more than 2 defective will be x will be 3, 4, 5, and so on up to infinite. So let us solve the first portion. So in first part, m is 3 and x is 1. So therefore, probability of x equal to 1, e to the power of minus 3, e to the power of 1 upon factorial 1. So this is your answer, 3 into e to the power of minus 3. Now you can put the value and get the result in decimals. Okay. So your final answer is 0.15. The second part, when more than 2 bulbs are defective, so therefore x will be 3, 4, 5 up to infinity. But in order to simplify, what we will be doing, 1 minus px equal to 0, 1, and 2. So this is the way of solving the question. So 1 minus, we can take e to the power of minus 3 as common. So 3 to the power of 0 upon factorial 0 plus 3 to the power of 1 upon factorial 1 plus 3 to the power of 2 upon factorial 2. So 1 minus e to the power of minus 3 is already available with us. Now you can put the value and get the result. Dimple is saying 0.1493. Yes, round off. If you do for 0.1493, you will get 0.15. And this is the symbol of round off. So if you are doing round off, you will get this. And if you are using exactly 1493, then also no worries. So 1 plus 3 plus 4.5. Now solve this. 1 minus 0.5768. No, 1 minus 0.4232. So after subtracting, you will get 0.5768. So this is your second portion. Okay. So Ritu is asking the weightage of the chapter. Weightage is around normally 4 to 5 questions come from this chapter because this chapter is divided into 3 portions: binomial, Poisson, and normal distribution. So some theoretical questions as well as some practical questions come from this chapter. Okay. So the result is 0.5768. If we round up, it is 0.58. So this was example number 16. Now, let's understand the 17th one. For 17, the question says the manufacturer of a certain electronic component is certain that 2% of his product is defective. So here also probability is given that 2% are defective. He sells the component in boxes of 120 and guarantees that not more than 2% in the box will be defective. So in a box, there are 120 components, and out of those 120 components, not more than 2% will be defective. So find the probability that a box is selected at random would fail to meet the guarantee. So guarantee meet out नहीं होगी, उसके chances क्या है? That we have to calculate. Okay. So first of all, what is the mean? So to calculate mean, n into p, 120 multiplied by 2%, it will become 2.40. 2.40. Then what about x? what will be the value of X? So it says not more than 2% will be defective. That means we have to meet the criteria for failing. Fail कब होगा? तो fail तभी होगा जब defective कितने होंगे? More than 2.4. That is 3, 4, 5, and so on up to infinity. So this is the most important thing in this question to calculate X. तो X हमने कैसे निकाला? क्वेश्चन ने कहा 2% से ज्यादा अगर डिफेक्टिव होंगे तो फिर क्राइटेरिया फेल हो जाएगा, तो फिर बॉक्स रिजेक्ट हो जाएगा. So what is 2% of 120? It is 2.4. तो 2.4 से ज्यादा अगर डिफेक्टिव है then it will be rejected. Therefore, value of X will be 3, 4, 5, and so on up to infinity. So, अगर 3 errors है, it will be rejected. In case of 4 errors, then also it will be rejected. So, therefore, X is 3, 4, 5 up to infinity. But in order to simplify this, what will be done? We will be using probability as 1 minus px equal to 0, 1, 2. इन सबको हमें क्या करना है? 1 में से लेस कर देना है. So 1 minus e to the power of minus 2.4, you can take them common. Then 2.4 to the power of 0 upon factorial 0 plus 2.4 to the power of 1 upon factorial 1 plus 2.4 to the power of 2 upon factorial 2. Now let us simplify. The value of E is given in the question 0.0907. Then 1 plus 2.4 plus 2.4 square by 2. So these are the values. So we have substituted the value. Now it's your time to calculate and get the result. So do your calculation on the calculator and get the result. So Dimple has given the answer 0.4303. 0.4304. So this becomes the answer. Okay. So Ritu has also given the answer. Ms. Khan has given. So this pattern is very easy actually. So 18 one. So let's come on example number 18. A discrete random variable x follows the Poisson distribution. Find the values of probability where x is at least 1. X is at least 1, which shows that x will be 1, 2, 3 up to infinite. So for this, we have to calculate 1 minus px equal to 0. तो जो इस x में नहीं है उसको 1 में से माइनस कर देना है. Now what is mean in the question? So you are given ex. Expected value is nothing but the mean. So mean is given 2.2. So let us apply 1 minus e to the power of minus 2.2. 2.2 to the power of 0 upon factorial 0. So values are given in the question. Let us apply. After subtracting, you are getting 0.89. 0.89. This is the first part. When probability of x is at least 1. Okay. Now, second part is a bit tricky. It says probability of x less than 2 divided by x greater than 1. So let's write here p x less than equal to 2 upon x greater than equal to 1. So it is in the form of p a by b. P a by b. So what is p a by b? The formula we have done in conditional probability. It is p a intersection b upon pb. A intersection b upon pb. So how to calculate this? So what is A here? A means x less than equal to 2. So this shows that x will be 0, 1 or 2. X will be 0, 1 or 2. What is B here? B is x greater than equal to 1. So we will be writing x equal to 1, 2, 3 up to infinite. Now, what is A intersection B? That is common between A and B. So 1 is common and 2 is also common. So 1 and 2, these are common numbers. So we will write 1 and 2. This is the intersection. Now you can simplify and get the result. So in numerator, we have to solve probability of x equal to 1 plus x equal to 2. Whereas in denominator, we have to solve x greater than equal to 1. So 1 minus p x equal to 0. So in this way, we will get the answer. So apply the formula e to the power of minus 2.2. This is common. Then 2.2 to the power of 1 upon factorial 1 plus 2.2 to the power of 2 upon factorial 2 whole divided by. Now 1 minus x0 we have already done in the first part, so we can write as it is 0.89. Now simplify and get the result. Substitute the values and get the result. So this value was already given 0.1108, then 2.2 plus 2.2 square upon 2 and then whole divided by 0.89. So your final result is 0.58. So in this way, you will get the answer. Okay. This was very easy. Now, Savitri has asked the doubt in 16.16. So let us clear that. 16.16. What was the main doubt is how to calculate M and X. So it is given that 2% of the bulbs are defective and there are 150 bulbs. So average mean will be. So mean is N into P. So 150 into 2%, that is 3. So 3 will become the mean. Now in first part, exactly there is one defective bulb, so X will be 1. And second part is more than 2 defective. So whenever more than 2 defective is there, the first values will be 3, 4, 5, up to infinity. But up to infinite, we cannot solve. So what is the way of solving? It will be 1 minus px equal to 0, 1, and 2. So always in this way, have to solve. So similarly, we have covered this pattern in 17th example also, and then in 18th also. So you can easily now simplify such kind of questions. Okay. So 18th question is done now. Now let us try the 19th one. 19th one is fit a Poisson distribution to the following data. Number of deaths is given, frequency is also given, and value of E is also given. So from this, we can easily calculate mean first. We have to calculate mean first. So the formula for mean, because X and F is given, number of deaths denotes X, frequency is F. The formula for mean is sigma Fx upon sigma F. So first of all, we are required to calculate Fx. So it is 122 into 0, 46 into 1, then 23 into 2, 8 into 3, and then last one into 4. So this is sigma Fx. So how much is the total? 120 upon total of frequency is 200. Therefore, mean is 0.6. So first step was to calculate mean. Now, what is the next step? Next step is to complete the whole table. Now, in this table, F is already available 0, 1, 2, 3, 4, and so on. Then, what is Fx? Fx is basically all the calculations which we have done here, like when F is 0. When F 0, we have to calculate, or you can write F x equal to 0. So e to the power of minus 0.6, then 0.6 to the power of 0 upon factorial 0. This will give us the value 0.5488. Then Fx equal to 1. So substitute 1 in place of x. Then Fx equal to 2, Fx equal to 3, and so on. So one by one, we are substituting the values as x, 0, 1, 2, 3, and so on. After that, we have to multiply with the frequency. Now, whenever we are supposed to calculate the frequency, an estimated frequency, or we say theoretical frequency, it will be capital N multiplied by the probability. So here Fx is the probability, and the given frequency in the question was N. So N was given, P is given, just multiply and get the result. Okay. So this was 122, 46, 23, 8, 1. All this was given in the question. So simply what we have done, we have totaled them, that is 200. Now 200 multiplied by 0.5488. Then 200 multiplied by 0.3293. So in this way, you can calculate expected frequency for each of them. Total will be same. Total will remain same. So this way, we have to complete this Poisson distribution table. So this is understood. Now, after this, we have to move on exercise questions. So let us move on exercise A. Exercise number first. Normal we will be covering on Saturday. So in set A, we have done up to 19th question. Yes. Now let's do some random questions. Which one is uniparametric? Yes. Uniparametric means single parameter. Uniparametric means single parameter. Now, in case of Poisson distribution, there is only single parameter that is known as mean. That is mean. So, if you write the additive property, like x follows Poisson distribution with parameter m1, y follows Poisson distribution with parameter m2. Therefore, x plus y will also follow Poisson distribution with parameter m1 plus m2. Okay, so this basically says that if f follows Poisson, y follows Poisson, then their sum will also follow the Poisson distribution. So x plus y will follow Poisson distribution with parameter m1 plus m2. So we will add the parameters. So therefore, Poisson distribution is uniparametric, that is having single parameter, only one parameter. 22. For a Poisson distribution which is equal or greater, so we know mean and variance both are equal. Option number B. 23rd. Poisson distribution may be unimodal or bimodal. Uni means single mode, bi means two mode. So it can be anything. It can have one mode or two mode. So option number D is correct. Then comes 24. Poisson distribution is, so it is symmetric, or it is positively skewed, or negatively skewed, or symmetric when m is 2, mean is 2. So which one is correct for 24? Let me know. Poisson distribution कैसा होगा, किस तरह से उसका कर्व रहेगा. So basically, when mean, median, mode all are equal, then it is symmetric. Then anything is symmetric. Otherwise, in general, nothing is written. That means it will be tilted. It will be skewed. It will be skewed. Then 25. A binomial distribution with parameters n and p can be approximated by a Poisson distribution with parameters. So what are the parameters of Poisson? One is n tends to infinity. Second is p tends to 0. Both are correct, but they are written separately. Option number C is having both the options. N tends to infinity and p tends to 0. This is also correct. But let's check D option also. It says NP remains finite. Yes. So whenever we are talking about P is very small, N is very large, but their product is a moderate value, average value. So NP is always a finite number, a moderate number. Okay. Then comes 26 for Poisson fitting to an observed frequency distribution. So for Poisson, what is required? Mean, median, or mode? We require mean, which is the most important continuous probability distribution. This we will be covering in the next class, that is normal distribution. So this is done. Then all these are questions based on normal distribution. Yes, question number 40. Number of misprints per page of a thick book follows. Now, in a book, there are thousands and lakhs of words. Now, how many words are having misprint? So the probability of misprint is very, very less, such that P tends to 0. So it will follow this distribution, Poisson distribution. Then result of ODI matches between India and Pakistan will be. So in such cases, the probability is not very, very less. It can be anything like 50-50, 40-60. So that kind of probability is large in number. It is a bigger number. So we can see that it will follow binomial distribution. Then wages of a workers in factory follow. Now wages can be anything. Wages can even extend up to infinite. It can be a large amount. It can be a bigger amount. Therefore, it will become a part of continuous distribution. And in the beginning of the chapter, we have studied that continuous means continuous के अंदर कौन सा distribution आता है, that will be normal distribution. Option number C. Okay. Okay, because Dimple is talking about question number 24. See, 2024, it is saying that Poisson distribution normally कैसा होगा? तो it is a skewed distribution. Skew का मतलब क्या होता है? किसी एक तरफ झुका हुआ होना, tilt होना. So it is normally tilted. And symmetry कब होता है? When mean, median, and mode all are equal, then only it is symmetric. Otherwise, it is always skewed. So now we have to do question number 9 from set B. So read the question first. So then I'm making some space here for writing. So question number 9. If the standard deviation of Poisson variant X is 2, find the probability. So standard deviation is given. So from standard deviation, you have to calculate mean first. What is mean? Mean is the square of standard deviation. So 2 square becomes 4. So mean is 4. Then what will be the value of X? So X lies between 1.5 and 2.9. So between these two, there is only a single whole number. There is only a single whole number, which is 2. Which is 2. So X will be 2. Mean is equal to 4. Now you can simplify and let me know the answer. You only have to simplify and give the correct answer. Mean is 4 and X is 2. So how much will be the answer? So apply the same formula, e to the power of minus 4, 4 to the power of 2 upon factorial 2. Upon factorial 2. So 16 upon 2 is 8. 8 multiplied by e to the power of minus 4. So Savitri has given 0.15. Dimple has given 0.147. Then Shrifaran has given option number D. Yes, so in this case, the exact option is not available here. The correct one is 0.147. The correct answer is 0.147. Then comes the 10th one. So everybody solve this question. Swati has done, Savitri, Dimple, Shri, and Ms. So in finding the probability that x takes the value at least 1. X is at least 1. So at least 1 means 1 minus probability of none. So 1 minus b x equal to 0. This we have to solve. Now, how to simplify this? So it will be 1 minus e to the power of minus m. Now, what will be the mean here? Mean is already given in the question, that is 1. Mean is 1. Then 1 to the power of 0 upon factorial 0. Now solve this and get the result. So 1 minus e to the power of minus 1, you will get the answer. Done, everybody? To solve and write the question, write the answers in the comment box and let me know your results. So this is question number 10. After that, we are having 11, 12, 13, I think up to question number 15 is there. Dimple has given option number C. Swati says 0.632, and Shreya also option number C. So everyone has got the same answer, 0.632. This was question number 10. Now, the next one. So before moving forward, let's take a break of 5 minutes and then we will be continuing with the remaining questions. So only a few questions are left now. So it will be easily done. Okay. So get back to question number 11. So beginning with the 11th one, if x follows Poisson distribution with parameter m. So कई बार question में directly Poisson will not be mentioned. आपको इस language से understand करना पड़ेगा. So this says x follows Poisson with parameter m, and its coefficient of variation is 50. So CV this time is 50. What is the probability that x would assume only non-zero value? x की वैल्यू क्या होगी? नॉन जीरो. दैट मींस x will be 1 2 3 and so on up to infinite. All these are non-zero values. Now इनको सॉल्व कैसे करना है? 1 minus probability of x equal to 0. Very easy. But there is one challenge, that mean is not given in the question. So how to calculate mean here? So what is the formula for CV? Coefficient of variation. It is standard deviation upon mean into 100. This is the formula for CV. Now value of CV is 50. Standard deviation is not available. So we can write neta in place of standard deviation. And what is mean? Mean is equal to variance. So we can write neta square in place of mean. 150 will get cancelled. Neta and neta will get cancelled. So we are getting standard deviation is equal to 2. So this shows that variance will be 4. And if variance is 4, that means mean is equal to 4. So we are getting mean as 4. So value of mean is 4. So 1 minus px equal to 0. So e to the power of minus 4, 4 to the power of 0 upon factorial 0. So let's simplify this and get the result. So you can put the values and get the result. Sadhu is asking about additional question bank are important or not. See, it's always better to practice as much questions as you can. So practice questions are mainly for your additional practices. So after completing all the concepts, you can try the practice questions. And in case of doubt, of course, you can reach to us and we are there to help you out. So no need to worry. So what is the final answer here? I think 1 minus 0.018 is there. So 0.982. 0.982. Yes, Dimple has given the answer. Option B. Option number B. Now comes the 12th one. If 1.5% of items produced by manufacturing units are known to be defective. So this is the probability of defective. That is P. What is the probability that in a sample of 200 items, this 200 is N, would contain no defective item? No defective, that means X is equal to 0. And what will be mean? It is 1.5% of 200. So 200 का 1.5% कितना होता है? It is simply 3. So m is 0, m is 3, x is equal to 0. Now substitute the value and get the result. So e to the power of minus 3, then 3 to the power of 0 upon factorial 0. So this is your final answer. Okay. All right. This was basically example number 12. Then Dimple is asking, Poisson is positive or negative skewed? It is positively skewed. It is on the right hand side. Right hand side area is more. So it will be positively skewed. Then Dimple has given the answer 0.05 for 12th. That is option number A. Someone is asking, I have text buttons in my calculator. Will it be allowed in exams? Yes, it's allowed. No need to worry with text. But the main thing is you must have GT button and memory buttons on your calculators. Okay. Then Ms. Khan and Savitri has also given answer option number A, 0.05. All right. Now, 13th one. Px equal to 1 equals Px equal to 2. Find the value of mean. So this is an equation and let us solve this equation to calculate mean. So e to the power of minus m, m to the power of 1 upon factorial 1. Then e to the power of minus m, m to the power of 2 upon factorial 2. So e to the power of minus m will get cancelled. 1m will also get cancelled. Therefore, mean is equal to 2. Mean is equal to 2. Okay. Now the next one. So 14th one, I think you can easily do. If 1% of airlines flight suffer a minor equipment failure in aircraft, what is the probability that there will be exactly 2 such failure in the next 100 such flights? So 1% is the probability, 100 is n. So you can find out mean as n into p. Then exactly 2 failures. So x is equal to 2. X is equal to 2. So this easily you can do. Now comes 15th one. F2 and is equal to 3 times of F4. F2 is equal to 3 times of F4. So this 2 is basically X and here this 4 is also X. So let us apply the formula. E to the power of minus m, m to the power of 2 upon factorial 2. Then 3 into e to the power of minus m, m to the power of 4 upon factorial 4. Now e to the power of minus m will get cancelled. M square also will get cancelled. So you are left with 16. No, factorial 4 is how much? 24. So 24 upon 2 you can write. And this is equal to m square. Now you can get the results. And also 3 is there. We can substitute 3 here. So m square is equal to 4. So mean will be equal to 2. Mean is equal to 2. So whenever such equations are given, just substitute the value in the formula and you will easily get your result. Then Savitri says your way of teaching maths is very easy. That's great. Okay. So this was 15th question. So up to 15 we have covered from set B also. Now let's move on some additional questions. All these are normal distribution based questions. Okay. So now let's take some random questions from additional question bank. So you can take out your additional question bank and now you have to answer. The first one, when a coin is tossed 10 times, we use. Now, since a coin is tossed 10 times, so 10 is a finite number, a small number. So it cannot be Poisson. So it will be a binomial distribution. Option number C. Because in case of a coin, you see that n is a finite number, positive number. Then the trials must be independent. So in case of coins, the trials are independent. Then only two outcomes are there and their sum is equal to 1. Therefore, option number C is correct. Then second is in binomial distribution, n means. What is the meaning of n? N denotes number of trials of an experiment. कितनी बार हमने try किया है? Then binomial distribution किसका part है? Continuous or discrete? Yes, it is a part of discrete distribution. Option number B. Then fourth one, when there are fixed number of repeated trials, so trials are getting repeated of any experiment under the identical conditions for which there are only two mutually exclusive outcomes. One is success, other is failure. Then we use. So all these conditions are of binomial distribution because number of trials are U in number. Then in binomial distribution, P denotes, what is the meaning of P? P denotes probability of success. If P is 0.5, then binomial distribution will be symmetrical. This we have done. Whenever P and Q both are equal, that is 0.5, then the distribution will be symmetrical. When P is larger than 0.5, when P is greater than 0.5, then what we have to do? When it is greater than 0.5, then we know that the values are not equal. So they are not symmetrical. So we will be writing asymmetrical. It will be asymmetrical. 8.1. Mean of binomial distribution. The formula for mean in case of binomial, it is n into p. Variance in case of binomial distribution, so variance will be NPQ. Then when P is 0.1, binomial distribution is skewed. So yeah, when P is 1, so Q will be 0.9. Therefore, it will be a skewed distribution. So let's move on some Poisson distribution question. 15. When the number of trials are large and probability of success is small, then we use Poisson distribution. When n is large, then and probability of success is small, so it follows Poisson distribution. In 16, in Poisson distribution, probability of success is very close to. It is close to 0. We know that P tends to 0. P is not equal to 0, but P tends to 0. 17. In Poisson distribution, NP is N into P is a finite or infinite number. So we have done that NP must be a finite number. Option number A. In cash distribution, mean is equal to variance. So when both are equal, in case of Poisson distribution, mean and variance are equal. That is, the value will be n into p. So 19 is again the same thing. Poisson distribution, mean is equal to. So mean is equal to n into p. Then 20th. Question number 20. In binomial distribution, standard deviation is equal to. Now the question is talking about standard deviation. So it will be root of NBQ, option number C. Then comes 21. For continuous events, dash distribution is used. So we have read this in our first section. Like when the distribution is continuous, we use normal distribution. So it will be option number A. So 21, option number A is correct. That is normal distribution. Then again, let's select some question from Poisson. #41. Let's come on question number 41. In binomial distribution, if m is infinitely large and the probability p of occurrence of the event is close to dash and q is close to dash. So when n becomes large such that n tends to infinity, then probability reduces. जब n बड़ा होगा, sample size बड़ा होता है, it increases, then probability decreases. So p tends to 0. So p की value होगी near to 0, then q will be near to 1, close to 1. So 0 and 1 will be the answer, option number A. Poisson distribution approaches a normal distribution as. Now, Poisson कब normal में convert हो जाएगा? So when the probability increases in case of Poisson distribution, so and n also becomes increase or n increases continuously because normal distribution is applied in case of continuous variable, and in continuous variable values fly from minus infinite to plus infinite. So Poisson distribution approaches a normal distribution as it increases infinitely. Then 43. If neither P nor Q is very small, the value of probability is not very small, but n becomes sufficiently large. That means n tends to infinity. So when n tends to infinity in case of binomial distribution, so it approaches Poisson distribution. बायनोमियल की जो प्रॉपर्टीज है वो धीरे धीरे पॉइसन की तरफ बढ़ने लगती है, so it becomes similar to Poisson distribution. Then 45. For a probability distribution, dash is the expected value of x. So expected value is also known as mean. Then 46. Dash is the expected value of x minus m square. So this is the formula for variance. 47. And this value of x is given, probability is also given, and you have to calculate mean. So mean is simply the product of p into x. So 1 into p becomes p, 0 into 1 minus p becomes 0, and p plus 0 is equal to 1. So therefore, p plus 0 is the result. So mean will be p. Okay, so 1 and 0 was in the x, probability was p and 1 minus p, therefore p into x will be p. Then 48. Question number 48. For n independent trials in binomial distribution, the sum of powers of P and Q is always n. So in binomial, we have done the formula nc0, p to the power of 0, and q to the power of n minus 0. So the sum of powers is always equal to n. It is always equal to n. So the statement is true. Option A. 49. In binomial distribution, parameters are, so we know that there are two parameters in case of binomial distribution. One is n, other is p. N comma p. Then all these questions we have already done. 54. Poisson distribution is a dash probability distribution. So किसका part होगा Poisson distribution? It will be discrete or continuous. So we already know this. This is the part of discrete probability distribution. Option number A. 55. Number of radioactive atoms decaying in a given interval of time is an example of dash. So since the time interval is given, if it is not given, then it will become continuous, and rate of decay is like very, very less, then it will follow Poisson distribution. 56. Dash distribution is sometimes known as distribution of rare events. Rare means उसके अकर होने के chances बहुत कम होते हैं. तो ऐसा कब possible होगा? In case of Poisson distribution. So Poisson is the distribution which is having a very rare chance. Then all these are based on normal distribution. Then there is a small point, let us cover that also today. That is uniform distribution. Uniform distribution. Now, what is the meaning of this uniform distribution? Let's say if we are taking a case having 4 outcomes. There is an experiment which is having 4 outcomes, 1, 2, 3, and 4. 4 outcomes are there. Okay. Now, what is the probability that first outcome will happen, or what is the probability that second outcome will happen? So, since this distribution is uniform distribution, it means that distribution having equal probability. Every event will have equal probability. So, since there are 4 outcomes, all events will be having 1 by 4 as the probability. So as we have done in case of coin, there are 2 outcomes, head and tail. So their probability of occurrence is half, and for tail, it is also half. In case of dice also, as we have seen, chances of getting number 1 is 1 by 6, 2 is 1 by 6. For each and every outcome, it is 1 by 6. So when there are 6 outcomes, the chances are 1 by 6. 10 outcomes, 1 by 10, 100 outcomes, 1 by 100, and in case of n outcomes, it will be 1 upon n. So this is known as the uniform distribution. Distribution having equal probability is known as uniform distribution. So let us have some question based on this. 61. A discrete random variable x follows uniform distribution and takes these values. So how many values are given? 1, 2, 3, 4, and 5. And what is the probability of having x equal to 8? So out of 5 outcomes, 1 outcome is favorable. Therefore, the required probability will be 1 upon 5. 1 by 5. So out of 5, only a single outcome is favorable. 62. Let's try one more. 62. This time also 5 outcomes are available. Now, out of these 5, what do we require? We require probability of x equal to 12. 12 आने के chances क्या होंगे? So क्या 12 given है हमें series में? No, 12 is not available in the question. That means no outcome is favorable. So 0 by 5 becomes 0. Then comes question number 63. So again, there are 5 outcomes given here, and we are supposed to calculate out the probability of x less than equal to 12. So 12 या उससे कम कितने outcomes available हैं? So 6, 8, 11, 14. So these are the 4 outcomes which is less than 5. Therefore, the required probability will be 4 upon 5. 4 upon 5. Option number B. So Dimple has given the answer. Then Shreya is asking about question number 15 from set B. Okay, let's take that also. Before that, let's complete 1 or 2 questions from here, and then we will be taking your doubt, Shreya. Okay. Then let's try the next one. 64. Probability of x less than 12. So out of 5 outcomes, 3 outcomes are less than 12. So 3 by 5. Then 65, x greater than 10. So 12, 15, 18, 3 outcomes are greater than 10. So it will be 3 upon 5. Okay, so this is done. Now let's come on again set B, question number 15. Doubt by Shreya Tiwari. Yes. So in 15, it was given that for a Poisson variable x, f2 is 3 times of f4. So this 2 basically denotes the value of x. 4 also denotes the value of x. So we are writing f2 is 3 times of f4. Now substitute the formula e to the power of minus m, m to the power of 2 upon factorial 2. Then 3 multiplied by e to the power of minus m, m to the power of 4 upon factorial 4. Now e to the power of m will get cancelled. So what is left now? M square also can become cancelled. So 1 upon 2 is equal to 3 into m square. Now what is factorial 4? Factorial 4 is 4 into 3 into 2 into 1. So 3 and 3 will get cancelled. 2 and 2 will also get cancelled. Therefore, m square is equal to 4. So what will be the value of m? Value of m will be 2. Okay, so this is the value of b. So in this way, you can easily get your answer. Okay, Shreya, the doubt is done. Then Savitri is saying today's class understood very easily. Great. Any more doubts to anybody? So whatever are your doubts, let me know. Shreya has understood. Okay. So let us summarize the topic, what we have done today. From this summary notes. Yes. So initially, the definition of Poisson distribution, a random variable x defined to follow Poisson distribution with parameter lambda is written. This lambda is nothing but the mean. This is basically mean. So x follows Poisson distribution with mean. We have done the formula e to the power of minus m, m to the power of x upon factorial x, where value of x lies from 0 to infinity. Then Poisson distribution is uniparametric distribution. Uniparametric means having only single parameter. Then we have covered mean of Poisson distribution. is denoted by mu, or it can be written as small m. If we have to compute the variance of Poisson distribution, then it will be equal to mean. So mean and variance both are equal. Mean and variance both are equal. Then, just like binomial distribution, Poisson is also unimodal and bimodal. Then Poisson distribution is approximation to binomial distribution. So when number of trials become very large in binomial distribution, so binomial tends to become Poisson distribution. So these two are quite similar because both of them are the part of discrete probability distribution. Then we have done the additive property of Poisson distribution. If X follows Poisson, Y also follows Poisson, then their sum will also follow the Poisson distribution. So all these we have covered. Now, in the next session, we will be talking about the last part of the chapter, that is normal distribution. So normal distribution is also quite interesting, but we have to take care how to calculate the values of normal distribution, how to see the tables. So that is quite technical, but it will become very, very easy with the help of diagrams, which we will be discussing on Saturday. Okay. So next is your explanation is too easy. Thank you so much, sir. That's great. So I think we have covered everything now. So in case of further doubts, you can reach to us on Students Clinic app, or even we will be meeting again in our next session, that is on Saturday, day after tomorrow. Okay. So till then, bye everyone. Take care and see you soon.